بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so this is the last lecture about Pandas data frame, and today we're going to make another use case which is about weather analytics. And the difference between this use case and the previous one that we have done yesterday, today we're going to talk about time series data analytics. Time series, it means that the data has temporal dependency. For example, the weather data, we can collect the weather either at daily basis or at hourly basis. So there is a time dependency. The x-axis is actually the time. And it has some certain characteristics, especially, for example, in this kind of situation in data science, we can do predictive models in time series. Because usually we can take some part of the history, and then when it has some patterns, we can make projection to the future, so we can anticipate what could happen, for example, after 1 day or after 2 days. And this is how they can make weather prediction. So sometimes they say it's likely tomorrow with 40% we're going to have, for example, rainfall. Okay, so they take several different parameters from the past, from the history, based on this temporal dependency. They try to identify patterns, and then they can actually make predictive models in order to tell what could happen. So I've taken a real data set of Riyadh weather. It was in November 2018, from 6 November to 20 November. It's a small data set, and we have data that is collected by hour. It's hourly data. You can see now this is year 2018, month 11, day 6, and hour 0, hour 1, hour 2, and these are the temperature collected I've taken from an official website. We have temperature data, relative humidity data, mean sea level pressure, and wind speed. Okay, and the objective here is to use Pandas data frames in order to analyze and interpret time series weather data using Python and Pandas. And usually in any kind of data science study, we need to extract meaningful insights and also try to identify patterns to weather conditions, such as temperature, humidity, and the different weather conditions that we've collected. So, of course, in any data science, we need to start with the data exploration and understanding, similar to yesterday. And what we need to do in this case? What is this first phase?
Load the data into a data frame.
Yeah, we load the data into a data frame, yes.
Use describe.
Yeah, we can use descriptive statistics to understand the data, information about the data types, and so on. So we'll do pretty much the same thing. It is like a standard for any kind of data analytic tools. You need to understand your data. You cannot make any model, or you cannot make any estimation if you don't understand your data. So first of all, we get familiarized with the structure of the weather data set. And here in Google Colab, if we want to import the data, so yesterday I did it on VS Code, today I'm doing it on Google Colab. There are just a few differences when you want to import your data. Now the data is available on my drive, okay, in this repository. So I have a data set here. So it's in this repository. And now, first of all, I need to mount the Google Drive to be able to access it. And this is the instruction on how to mount the Google Drive into your browser. So this will allow you to access content drive, which is this one. You look at the files. You have drive, so this is content drive, and you have all your data into my drive. You have then my drive, and you can access this folder until going to the dataset folder. Okay, so first of all, we're going to mount this drive, and then we're going to load the dataset. So first of all, you need to identify the whole path, the correct path to your dataset. And this is the path in my case. So I will share this with you. First thing you need to do is to change this path to be able to access the dataset, and then the name of the dataset, okay, which is Riyadh weather hour stat. So let me mount the drive. I already mounted, so I'm just going to restart the notebook. So if you do it for the first time, it's going to make a pop-up and ask you to log in with your account, and then, for example, your personal account. Then you will have access to load the data set. And we usually use .head in order to load the initial data. Okay, if I load, for example, now for 30 values, you will see every hour from 0 to 23, then it goes to the next day. It's going to collect all of them hour by hour. And you have the information about the temperature, the relative humidity, the mean sea level, and the wind speed. So let's make it for the first three. Loading the data set, and then understanding the data structure. Yes?
When I put the path from a file, it placed an R in the code before the path. Without the R, when I deleted it, it didn't work.
Okay, the most important it works, in your system.
Outside the system.
Yeah, in my case, it works just by putting the path. And understanding the data, of course, first of all, you need to call the dataframe.info. So here we're going to have all the information about and the different types. So we can observe that we don't have any missing data. Okay, we don't have null data over here, so our data set is complete. We have two types of data types, float 64 and int 64. And the memory usage is 22 kilobyte. Of course, it's a very small data set of 360 rows in the CSV file. You can also use .colon to extract all the columns here. And then .describe is going to provide complete descriptive statistics of all these data. Okay, so you can see the count, you can see the average value. So the average value here is 23 degrees during the observation window. For the relative humidity is 44, and this is for the mean sea level. You have also information about the standard deviation, the minimum, the maximum value, and the percentiles. So one of the things in time series data sets is the component of time. So look in our data set here, the time is expressed as the year, the month, the day, and the hour. So if we want to process it as a time series, so this is not considered a time series. We need first to modify the date and the time so that the data set is considered as a time series. So first of all, the first task, convert the date-related column, year, month, day, and hour, into a single date time column. So when we convert it to a single date time, so you will have a timestamp. This timestamp helps you to plot the information in the way that you want. So how to do that? We can create date time, okay, in the data frame, and we use Panda to date time. And here we provide the information about the year, the month, the day, and the hour. And so this is the date time that we created, and you can see now it's showing a timestamp. Yeah. And then we set the index, we set this date time as an index. So it's a temporal index. Okay, we assign the timestamp to be an index. Instead of having index 0, 1, 2, 3, it becomes now a timestamp.
Can you explain that?
Yeah, when you want to plot xy on an xy coordinate, you should have an index and then the value of the function. Now the index by default is from 0 to n. Okay, and now we want to have the index as the timestamp. So it shows you later on the graphs, shows you the timestamp 6 November, 7 November, instead of showing 0, 1, 2, 3, 4. Okay? You can also do some additional manipulations if you want by setting, need I execute this? By setting the time zone. Okay, so we can set it to the time zone Asia of Riyadh, so it will add +3 GMT. Of course, the next step now, we are just following the standard workflow of data analytics. We need to check whether, okay, we already observed that you don't have missing values, but if you want to check whether there are missing values, we can use isNull.sum over all the data frame, and here is going to return a data frame showing the number of null values that are detected. So we don't have any detected value. And in case you have one, you can fill it with the average. So usually in time series, if you have a missing information, in this case, it will be safe to either, so you can fill it with the average or with the previous value or with the next value, okay? So these are the common types on how to fill the missing values inside the data frame. If you want to drop them, you can also use drop NA.
So how can you make the previous one?
Sorry?
Instead of the mean, you want to make it as the previous one.
There is a syntax I used, I don't remember right now, yeah.
That also depends on the situation, right? Not always you want to
Uh-huh.
do this to the missing values.
Which values?
You said that with the missing values here.
Yeah, if we have missing values, we can process them like using replacing by the mean of the column. Okay. Yeah.
So, when you say dot is none, it means all the null values will be displayed in each column.
Yeah, is null, and you make the sum of all null values. I think I have a data set that contains null values. Yeah.
Okay, if it is a null value, how can it will be summed?
It will make the count of all values that are null. Okay, so this is going to return you the sum of the count.
The count.
Yeah. For example, if you have missing value in the month, it will tell you how many missing value is in the month, okay, in every field. Okay? Yeah. So D types applied to the data frame allows you to return all the typing. For example, here is int64, the month is int64. We have some float values like for the temperature and also for the pressure. In some cases, when you import values, although they are meant to be integer, they may sometimes be different. So you can manually fix the data types to ensure that the numerical value are correctly typed as integer or float. And you can convert any non-numerical column to be numerical. So how we can do that? We use pd.toNumeric. Okay, so this will be safe. If there is any, for example, value that has a string character or anything like this, so it's going to convert it automatically to string. And error covers ensure that any value that cannot be converted into a number will be replaced by not a number. So it will be equivalent to a null value. Okay? So this is applied to temperature, to humidity. You can apply it also to the other fields if you want, and then you can ensure that all your types are correct. Finally, after doing all this data handling and initial pre-processing on the data, you can explore your data by using .info and .head. So .info here is going to give a summary of the data set. We didn't do any changes because all the data is fine. So that's pretty much the same that we have observed in the beginning. And this is now the first element. Now, after doing the pre-processing, we are ready to go with the data analytics. So what are the possible objectives that we can do on a time series for weather analytics? We can try to analyze weather patterns over the time. Okay, so the first task here is to plot the hourly temperature trends. We want to see what is the variation of the temperature over the whole period of time. And here I make a combination between matplotlib and Pandas plotting capabilities. So basically, if I do that, these are just some decorations. I'm going to remove them. And we can just plot the weather by calling the .plot function in the data frame. Okay, so this is going to give you a plot like this. And since we have used a timestamp, so it starts from 7 November 2018. Now we can add some more options using matplotlib, which is a visualization library. So we imported matplotlib.pyplot as PLT. This is how we import usually matplotlib. So this is a short name for matplotlib, and then we can add more information. For example, the title of the plot, of the figure, the X label, the Y label, and whether you want to have a grid or you don't want to have a grid. And this is the size of the plot. Now, for example, let me try this one. So you can see the size of the plot becomes 10 and the height is 6. And here, this is the title, hourly temperature between 6 November and 20th of November. Yes, just a moment. And this is the variation of the temperature at hourly basis over the observed period of time. Yes.
Can we plot the highest temperature of each day?
You can do anything. Highest, average, box plots, anything, it's possible, yes. There are different types of plots that we're gonna discover them when we talk about matplotlib and seaborn.
Only the functions, or do we have to assign values for each day? So, for example, in day
No,
one-
first of all, you set your objective, what you would like to visualize. And based on the objective, you can choose the proper plot type. Okay? There is histogram, there are pie charts, there are box plots, there are heat maps. It depends on what you want to plot. All of them are available. Yes. And in the slides, because most of you would like to have lectures using live coding, in the slides I put all different type of plots. Okay, so I will share with you the slides. They are comprehensive. But of course, in one lecture we cannot go. I want to show you the main concept. And my focus is not only on the Pandas syntax, is on the way of thinking when you conduct a data analytics study. Okay, the Pandas syntax, you can find it in everywhere, but the most important thing is to have the right approach to tackle any data analytics study. Okay?
Sir,
Yeah.
before you used matplotlib, when you called dot plot on the data frame, it printed plot. But now, so how did you decorate it after calling plot?
Okay, let's make it one by one, you know. All of these are just simple details. So here matplotlib allows you to have more control over the plots. Okay? So the plot now, we have one control, which is the figure size. I can, for example, increase it if I want. Okay? So you can see, you can control the figure size. And then I want to add a title. Okay? So just putting the plt.title is going to add the title over here. And then you can add all the different other options, like for example the X label, it's date and time, and then it's going to put the temperature in the y-axis. Okay, these are some additional controls that you can do over your plot.
And what's the dot show?
Dot show, this is something we need to do for showing all the options. Now it works, but in matplotlib usually when you do all the different options, we finish by plot.show. We give an instruction to show the plot.
And it works because Panda itself, the plot function in it is from matplotlib as well.
Yes.
That's why it works.
Actually, this plot function is part of the matplotlib. Okay, so Pandas is based on matplotlib for visualization and NumPy for data structure. Yes.
So now in the industry, these tools are being used more than Excel and other.
In the industry, most of the tools are used is Excel, unfortunately. These are advanced for companies who do advanced data analytics. Yes, of course. And usually we use Python when we have web application backend that we want to use data analytics, develop data analytics application in the backend to process the incoming data, either, for example, in IoT applications or artificial intelligence or any kind of data that you want to analyze in the background. So we use these type of tools. There are other also visual tools like Tableau and Power BI. They're pretty much popular in the industry. They have visual, but Python can give you a lot of flexibility. So you can define a pre-programmed workflow, and then you just need to call it on your data so to visualize it. Yes.
Can you store the plot in a variable?
The plot in a variable.
All of our methods.
Why you want to store the plot in a variable?
Because here we always use PLT. Does that mean we can only modify one plot at a time?
Yeah, you can define different type of plots. in Matplotlib, like using variable. You can define axis. There are plenty of options available. Yes. Okay. Now, what do you observe in this plot? A lot of fluctuations. Why? Now this is the data analytics spirit. So why we have a lot of fluctuation? Is it normal?
Night and day.
Huh?
Night and day.
Yeah, because we have low temperatures at night and higher temperature, and you can see the variation in Riyadh is pretty much big. Sometimes it's 20 degrees in one day. Okay, so we can observe that there is a huge variation in the temperature even during November, which is kind of beginning of the winter. And so one of the things we can do, instead of having this at hourly scale, we can make it at the daily scale. So we can smooth the variation by seeing the average in each day. So this can give us another perspective in a time series. So in a time series, depending on the granularity of your data, you can aggregate it, okay, into coarser grain granularity. For example, here we collected by hour. You can make it by days, by week, or by month. In this case, I cannot make it by month because I have a limited data set. But imagine that I have a data set of 3 years or 4 years. We can aggregate it by year, we can aggregate it by month, or by week, or quarter, and different types of here. So here we can aggregate it by day and by week. We have 2 weeks. Okay, so this is what we call resampling. Resampling. Sometimes you might have a data that comes every second, every minute. So you can do resampling to have a more general understanding about what is happening within a certain period of time, instead of having just looking at micro scale or macro scale. It depends on the granularity that you want to observe. And here there is dot resample, and because we work with temporal data, so we can specify D character, it means daily. And here we will take the average of all temperatures into one day, and this we consider this is 1 point. So how many points here? From 6 to 20, we're going to have almost 15 points. It's 2 weeks. Okay, so let's try this. So we're going to have daily data. It's a new data frame that varies at daily basis. Look, 6, 7, 8, 9, 10. And we have here, and here we're going to have the average temperature every day. And then we can visualize it as well. So we can visualize the daily variations. Okay, let's focus on the code. So we're going to choose daily data, temperature, humidity, and wind speed. And we can visualize the variation. Of course, if you want only to see the temperature and the humidity, that's possible. So you can remove. If you want to see only the temperature, you can remove this one. Okay, so you can see the variation, and here it can give us a clear shape of the trend. Okay, and the trend, its temperature is decreasing, and this is normal because as we are closer to the winter, we're going to have lower average temperature. But if you look at this, there is a trend, but it's not as clear as the other. So here it's smoother. The variation is smoother. We can have up and down, but the variation is much smoother because here we observe day and night, and there is a huge variation every day. But if we take the average, we're going to have a better observation related to these values. Okay, and we can change this to make it by week if I want. Look, how many values we will have? 3 values. Okay, let's visualize. Okay, look, the temperature is clearly decreasing, and there could be some variation for the humidity, small variations also for the wind speed. Okay, of course, if I have a larger data set, I can make it by year, or I can make it by month as well. If I do by month here, I'm not going to have anything because I don't have, so it's only one value.
hour up when we assemble, what was the hour?
Where?
Up in the table.
Where exactly? Here?
Yes. What is
When
the
we
hour?
sample?
Yeah,
So here it seems it made the average. So the average between 0 and 23 is 11.1. So here there is one missing maybe value. Make it 10, and then it's the average. It's average of everything.
So how do we resample that on something other than time?
You resample, we talk about time series.
Hmm.
So you resample with respect to the time granularity that you want. We work with time series data right now.
Yeah.
Okay, yeah. There are other ways to, it's not resampling, but smoothing. I'm going to talk about smoothing over rolling windows. And visualize the daily average. So we finished with this. And for example, we can also investigate the days and the nights, the difference between the days and the nights, the temperature. So in this case, we can take, look, you can use between time. And these functionalities, you cannot use them only if you have a time series. And if we didn't do the timestamp like this, we couldn't have utilized any of these functionalities. So now we're going to create a data frame for the daytime, which is between 6 a.m. and 6 p.m., and the other one between 6 p.m. and 6 a.m. So this will be the night, and we'll calculate the average value for the temperature of the daytime and the nighttime, and finally visualize both of them. So here we found that we have different values, and this is normal because we have taken a long period of time. Now, if we look at the day in November, so usually it may start the sunset. When is the sunset? Let's say around 7:30, and it will finish sometime around like, let's say 5. And now we will make it from, 5 it's 17. And here we will make it from 17 to 7:30. So here you can observe some differences. Okay, this is 24, and this is 29, it's 23. It depends on the range of the time that we're going to consider it for the day. Okay, if we take it smaller, for example, from 16 to 8:30, like the daytime, 16 and 8:30. We're going to have bigger difference. Okay, still 24. Okay. So one of the other things that we can do on time series also is what we call moving average. And the objective of the moving average is statistical technique to smooth the data variation. So we have observed in the first plot that we have a lot of fluctuations because the observation time was at hourly basis. And then we made a resampling for a day basis. So the resampling of the day, it's equivalent to having a moving average of 24 hours. It means if you have a window of 24 hours, this is going to be a full day. Okay, so the benefit of moving average is to reduce the noise of the data, making it easier to observe underlying trends. And also, it helps to detect patterns and trend detection, predictions, and also allows to make better comparative analytics. Look now. And there are different ways on how to do smoothing. Now, I considered here a moving average over 24 hours. Look at this plot. And for this, we use a rolling window, and the window size is 24. It means it's going to span 24 elements and average them together. Then it goes to the next 24 elements, and then the next 24 elements, and so on. And this is the result. So this point is the average of 24 values. Another point is also an average of the next 24 values. And this is the rolling average. Now, if I change this one, for example, every 6 hours, look. Now, if I want to make it at hourly basis, the window is equal to 1. So every value is an average. So, okay, it's the same plot that we made in the beginning. Now, if I smooth every 6 hours, so it's going to take an average every 6 hours. It starts to be smoother, but still there are fluctuations. Now, every 12 hours, smoother. Every 24 hours, it's even smoother. So this is similar to, it's not equivalent to resampling at daily basis, because the daily basis I'm going to take a full day, calculating the average, then I move completely to the next day. The moving average now is going to take first 24 values and then just switch by one element and takes the next 24 values. So there is a difference between the time window. The day resampling, I'm going to take independent and non-overlapping windows. However, in moving average, the windows will be overlapping every time. And if I take for 48 hours, okay, I'm going to have even, so we can see the trend better. If I take it over, for example, 2 days or 4 days, 96. So this allows to see the trend much better. See what I mean? Okay, so it gives, it reduces a lot the noise, and we can see the trend. So I can see that the temperature was decreasing, but at some point was stabilizing for a couple of days, and then decreasing sharply. Okay, so smoothing the lot of fluctuation, it helps you to have a better understanding of the trends of the data, and this helps actually create predictive models. So now I can predict that probably in the next few days I'm going to have the temperature reaching to this point, and this is how we can predict the temperature for the next couple of days. Is we have to look at the previous trend. ما هيش نبوة لأنه we don't bring anything from scratch. We are observing, and then we are going to base on the trend to be able to predict with some confidence. And of course, there is no 100%. There is some confidence that can go plus minus 5 with 95% of confidence interval. The temperature is going to fall within this range. Okay? So this is how we interpret this type of statistics.
What's the difference between making the roll per day and reassembling as well per day? Isn't the same average?
Who can respond to your colleague? Yes.
Yes, rolling is a moving window, so we take the first 24 and then we move only one element. And
Yes. They are overlapping ranges.
We move.
And the other one is non-overlapping. You go day by day. واضح؟ Okay. Okay. So another thing, there are plenty of things, we're just exploring on the capabilities, but there are more capabilities that we can present in one lecture. But I want you first to focus on the critical thinking about how to address these things, understanding this plot. I don't care about these instructions in Python. You can find them. But if you want to be a data analytic engineer, you must be able to leverage this Python instruction to get insights. The most important thing in data analytics is to get insight out of the data. Okay? Of course, part of the skills is to know how to develop these type of tools. Okay, how to work with these type of tools. But the most important skills, when you go for a customer, you're not going to say, I used Pandas data frame and history. No, you're going to explain the data patterns. You're going to explain the insights and the critical observations. Okay? And these tools, actually, you can leverage these tools in order to get these insights. And generate descriptive statistics for weather variables. This is same as described, but you can also choose what kind of metrics you want to have the statistics. There is nothing new over it. Another thing also that you can use is to analyze the variability of the weather condition. How much variance there is in each type of metric. So how we can do that? Using the standard deviation or the variance. Now, if I take the data frame, I calculate the variance and the standard deviation of the temperature, the relative humidity, and the wind speed. So now I have some results. So how can you interpret these results? Now for the temperature, for example. How do you interpret this result for the temperature? What does it mean?
It means that there is change by almost 4.6 Celsius.
Yes. It means during the observation window from 6 November to 20 of November, there is an average variation of the temperature of 4 degrees. This is how we interpret it.
And the variance is 21.
The variance is the power of 2, okay? Is the square. Is the square of the standard variation. So the standard variation give you like an estimation of the variance of each type of metric, or weather condition. Now the humidity, there is a variance of 19 units of humidity in the observation window. Okay, so there is more variance in the humidity. Maybe this is related to the rain. Maybe some days were rainy and some other days do not have rain. And this is also for the wind speed. Okay, identifying extreme weather conditions. So in this case, we will observe the minimum and the maximum values of each metric. So we can take the maximum and minimum. So we can see the minimum temperature was 13 degrees and 33 degrees. So there is a huge variance between both. And this is for the wind speed also, maximum wind speed. We can also analyze the relationship. What does it mean? Is there any correlation between the temperature, the humidity, or the wind speed? And for this we can use the correlation or the covariance matrix .col, the same that we have introduced yesterday. And this is going to give us this correlation result. So how do you interpret this correlation now between the relative humidity and the temperature?
Between relative humidity and temperature?
Negative correlation means one is higher.
Yeah, what is the negative correlation? That's one observation, negative correlation, yes? They are inverse. If one increases, the other will decrease, okay? And how do you qualify the strength of the correlation?
1 is the highest and 0 being the lowest. So
Yeah, 0.15 or 0.6 correlation. It's kind of weakly strong correlation, not very strong, okay? Yeah, moderate correlation between the temperature, and they are negative. And of course, you can analyze all the other. For example, there is also a correlation between the temperature and the wind speed. They both increase together. And okay, so this is how we analyze. There is a moderate negative correlation, meaning that the temperature increases, the relative humidity tends to decrease. Okay, there is a positive correlation between the temperature, and this is the most important, is to get insights. Okay, all these statistical tools, you have had a statistical course, but in data science, we use statistics to understand facts about the study that we want to achieve. Okay, this is the most important. We can talk a lot about Python, Pandas, but the most important thing is to get this culture of having an understanding about your data. You must be able to analyze your data, to make critical insights about your data. And you have a lot of tools that you can use. One of them is Python. There are so many others. But the most important thing is that you have the attitude and the skills of data analytics scientists. We can use also scatter plots to show the relationship. Okay, so here, this scatter plot shows the dispersion of the temperature data, and here there is, we use the library Seaborn. It's another library that is built on top of NumPy. We're going to have some introduction about this. And this allows to show this scatter plot, which shows the spread of the temperatures compared to the relative humidity. So what do you observe here? You have a negative trend. So this confirms the statistical correlation that you have found. It's negative. If one increase, the other one decrease. It's not very strong because you have kind of a dispersion. Okay, if we have it strong, it's going to have pure linear relationship. We don't have a pure linear relationship here. So you can see that the visual graph complements the other observations. So If you want to expose your data, instead of saying we have 0.55 correlation, no, you show him a graph. And from the graph, the stakeholder can understand better the trends of the data. You can have also illustrated with a heat map. A heat map, for example, low correlation is in blue and high correlation is in red. And in between is actually, you can see the strong and the weak correlation here. Okay. So we're gonna stop at this level. It's time. There are still some other plots. I'm going to share with you this notebook. And after vacation, we're gonna start with NumPy array, inshallah.